bacterial locomotion actually is an assembly of run and tumble motion. Look about the, this is an YouTube video. Oh, yeah. So look, this is actually bacteria actually moving forward. This is actually, it is called run. And look, that bacteria, oh, sorry, I am playing again. Yeah. So look, that bacteria is actually in pausing mode and it is changing its directions. Yeah. So it is called the tumbling motion. So now, so again, you can see this is the run motion. Bacteria is moving forward and this is the tumble motion. So it is making some pause. Yeah. So it is called tumbling motion. Now, if you see it, oh, it is not. Yeah. So okay. Yeah. So if you now see, so this is the run motion. So where actually bacteria moving forward, and this is the tumble motion where bacteria making some pause movement. It is called tumble. So from experiment, it is actually, I am telling you the conceptual, the what is actually now going on, not in the Marban theory. Yeah. So, and in this field, Professor H.C. Berg in Harvard University, he is very pioneer in this field. He did his lot of experiment on to cultivate this field. Yeah. And he actually observed, and he maximum actually he did his work and on that field. He suggests that during run motion, so this filament, so if you see, this is the bacteria, so this is the cell body, and this is the hook, and this is actually the filament. And overall, it is called the flagellum. Yeah. So when during run motion, flagellum rotate in the CCW rotation, anti-clockwise rotational, counterclockwise rotational direction. And in the tumble mode, it is the flagellum rotating in the clockwise direction. And this is actually how actually you can explain this run and tumble motion. So you can explain is, so this is the cell body. Okay. So now I am coming the concept swimming on bacteria. You can explain to the resistive force theory of hydrodynamics. I am coming to the concept of mathematics. Yeah. So see, this is one only monoflagellated system. Yeah. So only one flagellum you can see from, you can consider for simplicity. Now, if you see, this is the cell body. This is the helical filament. Yeah, is there, and now it is rotating. Yeah. So basically, bacteria moves at a low Reynolds number. Do you know what is a low Reynolds number means? So low Reynolds number indicate whether it will be the media will be turbulence or not. At low Reynolds number, there is no turbulence. Yeah. So bacteria, you can, I am not going details about the hydrodynamic concept or about that. Yeah. So it is usually you can see the Stokes regime. Yeah. So you can, and if you see, it is the, oh, sorry. Minute. Yeah. So this is actually rotating in the counterclockwise direction. If you consider it is rotating in the counterclockwise direction, then and this is the radius of the filament. This is rotational. This is, through this radius, it is rotating. Now you can see. You can consider one small segment. This is a small segment of the filament. Now this is the radial velocity u. You can consider u equal to omega into r. Omega is the angular rotational angular velocity. You can understand. Can you understand that? Yeah, this is basic physics. Yeah. So now it is called. So you can just divide it in the vector just notation. You can just decompose into two parts. This is parallel component and it is perpendicular component, and it making some angle theta like that. Say this is a theta. So this is u cos theta and u parallel equal to u sin theta. Now, according to resistive force theory, you can see that in the Stokes regime, the repulsive force, yeah, so it is not acting just opposite to the u. It little bit makes some angle f. Yeah. So if you decompose this, uh, so you can parallelly you can decompose in the two part, F parallel and F perpendicular. Then you can see there is one resultant component Ft. You can write in this expression F perpendicular cos theta, F parallel into sin theta. And also you can see this is one, another component is there, Fp. This is F perpendicular sin theta minus F parallel cos theta. So this actually this force is the propulsive force. So this force helps the bacterium to move forward. So if bacterial flagellum, one flagellum rotate in the counterclockwise rotation, from resistive force theory, you can see there is one component. This component actually just pushing the just pushing the bacteria. Yeah. So that's why bacteria moves forward during run motion. And for count one, for that actually, this is actually, it is called a symmetric type of motion. It is, so that's why as filament rotating in the counterclockwise direction, so cell body rotate to oppose that reaction, cell body rotation, cell body rotate in the clockwise direction. Yeah. So this is the general concept of the hydrodynamics. So now, so this is a reference. You can actually write these references. This is a very nice paper. Eric Lauga-Elter. He is in Cambridge and he is in Department of Applied Mathematics. He is working mainly in this bacterial hydrodynamics. Yeah. So now I am coming. So if you see the in the run motion, so you can understand there is, it is called each and every filament actually producing one propulsive force. This force is acting that direction. So this filament also acting that direction. So if you see that just vector calculation, you can see there is some net propulsive force definitely acting in the forward direction. And for that bacteria move forward. Now, if you see in the tumble mode, Fe actually this propulsive force acting in the opposite direction and in this direction. So this is just so and when actually it is rotating in the counterclockwise in the direction, clockwise direction. In this rotation, it is counterclockwise, and this is the clockwise direction. In clockwise direction, if you just actually simply you can just make some calculation, you can understand that the propulsive force definitely acting in this direction. Yes, in the opposite direction. You can prove it. Yeah. So that's why actually Fp acting in the different direction, and there should Fp net should be 0. So that's why tumble motion happens. So this is actually the simplified version of the hydrodynamics theory. I am telling here, there is another lot of theory are there, but I am not coming details. So and also observe, it is from also from experiment, this is observed that during the run motion, this hook become soft and rigid. Sorry. Oh, sorry. I am making one mistake. Hook becomes soft and flexible. Okay. And so this is actually, you can see this is the Brown et al. Actually did this experiment. So he is also belongs to the HC bar group. And during tumble motion, hook becomes straight and rigid. So that's why actually this FP net becomes 0 and acting on the opposite direction. This is an explanation why run and tumble motion actually happens. Now, I am coming the more actually microscopic. I want to give some more microscopic description. So say why bacteria actually this filament actually rotating in the counterclockwise or clockwise direction. So say this is the run motion. So this is actually this is in the counterclockwise rotation is happening. Now, if you see this overall flagellum structures, then you can see this is the bacteria. So this is this flagellum actually composed to it one filament, and it is connected with one bacterial flagellar motor. Yeah, and it filament and BFM connected through the bent hook. It is actually bent, remains CCW direction when rotating, and in CW rotation, it becomes straight. So now why actually this rotational transformation occurs? So now if you see in the tumble mode, then it becomes straight, the filament becomes straight. Yeah, and it changes in the its rotational direction. So this is actually due to the reason of the one phosphoregulator signaling protein, CHYP. It actually binds at the lower portion of the this motor. This is usually FLIM and FLIN protein. I am not going into detail because my next speaker will give details about the structure. Yeah. Okay, and KMM sir will describe. Yeah, so about the molecular structure of the BFM. Now it is actually the traditional concept. Yeah, so this signaling protein actually binds to the lower portion of the this BFM. Yeah, and that's why this CHU, this rotational direction changes. Yeah, this is the concept. Now, is the motor torque and speed is measurable? So AC Bark actually measured this rotational speed and torque. I am giving the experimental details little bit, yeah, just introductory level. So suppose this is a multiflagellated bacteria. So now, first actually it truncated all of the filament except one. Yeah, so except one. So then it actually emerges in the viscous medium and is strictly attached with a glass cover sleeve. Yeah, so it emerges in a viscous medium. Then actually you can see this one bead, one bead is latex bead is actually attached with this truncated filament, and you can observe that the bead is rotating. Yeah, the rotational, you can observe this rotation of the bead. So why BFM rotates? Because they actually think that BFM, this bead rotates as actually this filament, and the filament is attached with the this bacteria flagellar motor. So as BFM actually rotate in the counterclockwise direction, that's why actually BD is rotating. Yeah. So this is the experimental setup. So how they can measure the motor torque? So this is the, you can see that this is the revolution motion. And now motor torque is calculated as, say, this is the motor torque and this is the rotational drag coefficient. So drag means, rotational drag coefficient means, so if you actually rotating, if this latex bead is rotating in the viscous medium, yeah, so it faces some friction. Yeah, so this is actually frictional force actually. It is called you can think the rotational drag coefficient. Yeah, so the rotational drag coefficient of motor, and this is the load. It is actually called the, in experimental language, you can say this is a load. So this size of the bead you can vary. Yeah. So and you can get the different speed. So you can get the omega for different values for different bead size. This is the experimental technique. Yeah. And where's zeta L, actually you can measure, and this is the RB is the radius of the bead, and eta is actually the viscosity of the medium. This is the standard technique. Yeah, so it is described by A.C. Bark in actually Harvard University. So you can see this is the reference. Now, surprisingly, if you actually, so you can measure, experimentally you are measuring omega, and then from that equation you are calculating tau m, torque. Then actually, if you actually plot omega m versus tau, then you can see for for CCW rotation, so there is one plateau-like region. Then after one certain phase of one speed value is certainly this velocity goes to zero. It is called a knee speed. However, in presence of the CHEYP, this signaling protein, this omega relative torque versus speed value decreases linearly. Yeah, so there is some asymmetry. So actually, I am not going to the details about that, but this problem remain unsolved. Why it is occurring? So I solved that problem. Yeah. So it is almost 14 years old problem. I solved that problem. But actually, I considering this the traditional concept, not Murban concept. Yeah. So now I am not going in details. So now actually, this is actually the high viscous loads. And this is actually medium viscous loads, and this is the low viscous. So low viscous load means the bead size is small. Yeah, and the high viscous load means bead size is very big. Yeah. So now, if you see, so this is the asymmetric in nature. 1 minute. Now, if you see recently, you can see one picture. Yeah. So you can see this is Simogonia et al. Actually did this experiment. You can see torque-induced precision. So yeah, you can see bead is rotating and it is actually making the precisional motion, not only revolution. Yeah. So you can see this is the precisional motion. The bead is performing precisional motion. So that's 2015. It is published in scientific report. Yeah. So yeah. So you can see this is the precision is observed. You can see this is the so precision. You can see from physics concept, precision is the resultant of the revolution and spin motion. Yeah. So precision actually observed. You can see the revolution as well as spin motion is observed. So in my work, I also considered these two type of motion, and I explained this asymmetry. So now actually, this truncated filament and bead exhibit precision motion. Now, a question is that in this case, so bead is, according to the traditional concept, BFM is rotating, and that's why bead is rotating. So BFM actually rotational of due to rotational of the BFM. So spinning motion of the spinning motion, you can observe the spinning motion of the bead. Yeah. But why actually you can see also the revolution motion. So why it is actually happening. So you can actually also describe to the hydrodynamic theory or vector theory. But now I can see that molecular mechanism of torque generation. So if you see the BFM, this is the filament and this is the hook, and here this is the FLIGC protein is there. So it is concept, and this is the stator. Yeah. So H plus ion mainly enters from periplasm to cytoplasm through the stator. Yeah. And it contacts with the FLIGC protein and makes a power stroke. What is power stroke? Power stroke means just a push like that, this type of force. This is called a power stroke. Yeah. So uh, according to this normal concept, actually, that what is the torque generation mechanism, I am explaining little bit. So stator can stay in the two conformational state. One is a stator without proton, and another is the stator with proton. So two proton can enter into one stator protein, and there is 8 to 12 non-rotating stator. So 2H plus when actually say this stator MOTA and MOTB protein, actually KMM cell will explain later rigorously about that. Yeah, regarding this concept, where actually Murban concept is needed. So I am actually explaining the what is the concept is now in literature. So now actually, so 2H plus, so there is two, say, piston like that. Yeah. So this is MOTA protein. One MOTA protein, actually when H plus ion comes, it just moves onward and it down. Yeah. Moves up and down, and it makes out to one power stroke. First power stroke, and this is the second power stroke. And it pushes the FLIG protein like that, this rotation. And that's why this rotation of the FLIG motor, actually FLIG protein or rotation of the motor is happens. Yeah, this is the concept. And when CHIP protein actually bind to that seeding complex, it changes just the direction of the FLIG proteins, it changes. This is the structural actually study. It done by Paul et al. It is published in PNS. You can see this the direction of the FLIG protein is just changes. It's changed. Yeah. So if you see the structure of the this direction of the FLIG protein is just changed in the direction, you can easily explain the CW and CW rotation. So this is the concept. Now you can see why CCW rotation. So this is the I stator. It is making one this force is there, and this is actually the Z axis. So you can see from the torque relation, you can see this is the tau. This is the stator rotor interaction. This is the torque is acting along that direction. This is the radius, and this is the force. So it is working. It is rotating anti-clockwise. And now if you see in this CCW direction, just you can explain it very simple just vector model. Yeah. So now you can also just it direction is changed. Now question is that now I am coming. So why Marban? This is actually the very brief summary of the already existing theory and literature, and why actually I am actually feeling that why Marban concept is needed. Because see, I already explained that 1 minute. Yeah. So H plus ion is coming from periplasm to cytoplasm in both rotational modes. So H plus ion always coming inside. But in literature, there is no such, actually, I don't know, according to my best of my knowledge, actually, there is no mechanism how H plus ion, so H plus ion is entering, but if H plus ion always enters into the periplasm to cytoplasm, so pH will change, yeah, inside. So how actually bacteria maintain its pH? So I think in this regard, yeah, so this is I already mentioned. So if, and for that perspective, actually to get the answer of that, yeah, I think uh, if I use the Murban concept, I can explain how bacteria actually maintain its pH if H plus ion or continuously entering into from periplasm to cytoplasm. So this is actually and the reason that's why I am interested on Murban theory. But later actually KMM sir will describe details about the already existing concept, where is the drawback or what is the blah blah blah. Yeah, so you can you can listen. Yeah, so that is I think for that is enough. Yeah. Okay. Yeah.
Hear me? Hello? Okay. So, how they, thank you so much. So, he gave the classical, contemporary, thank you. Okay. So, he gave the Professor Dr. Das gave the mathematical explanations of sophisticated interpretation of bacterial flagellar motility, flagella assisted motility. Okay. Now, I'm going to shred whatever he said into pieces. He's, why? Because he spent a lot of time building upon so many things that was already built. And the kind of sentiment that he expressed, that is, when we don't check before we do a work, what did I always do? Explore, resolve, prioritize. All right. So mathematicians and chemists and physicists, when they get into biological system, biology is highly information centric. Yes or no? Too much. This name, that name, that name, this name. Physicists go, nah. Mathematicians go, like that. So now I'm pretty confident what I'm saying is true, but I'll keep my mind open regardless. Let's get some terminologies clear. Uh, Rotational. What is rotation? Repeated circular movement of the rod along an axis that passes through a center of symmetry on its own body. All right. Then revolution. The body traces a circular orbit around an external locus as its center. A stone tied to a string forces swell around. Spiral or helical, the movement is around an eccentric locus, but the space-time coordinates are not periodically repeated in exact terms. For example, a flower or something falling down like that, right? That. Torsion, right? You go, comes back, some spring assisted or some movements like that. So I'm just getting these words very clear. What is it's called? Paul Boyer's explanation is rotary ATP synthesis. There is torsional ATP synthesis mechanism. There are many kinds of proposals. Okay, so now these kinds of but in natural, in spontaneous living systems, Howard Berg, whom he mentioned, he passed away last year. Good for him, because it would have been sad for him to live to see he was a good scientist, was a meticulous scientist, but then sad. So ways to rotate a rod. I'm not an engineer, but when you see how can advection, see your rod, fluid can be applied. It can flow like this, the rod will rotate. Okay. Then direct torque, you apply something in, and then you can rotate that, and by virtue of that, that will. Then gears, you can connect it to gears, gearing or belting, you can have it move. So these are the ways to rotate a rod. Then yet there is yet another way to rotate a rod, that is by electromagnetic induction, right? How you have the motor generator, that assembly, basically magnetic field, and you use bushes and all that, and then you rotate it. This is the simplest way. Now, I want you to see the bacterial flagella. I want you to see where it falls. All right, these are the tangible, real ways. Now, proton has a charge, it comes in, but is it mechanical? Is it electrical? Is it chemoelectrical? Is it space? How does it happen in real space with respect to real force? How was something that people saw an observation? How was it interpreted? And how was it put with respect to real concepts of physics? And I'm a biologist. I don't know all these sophisticated things, but this is the structural aspect. So GPCR, transducin, you saw in rhodopsin, that was so big. Complex 5 is so big. This guy is huge, humongously big. All right, and it spans multiple phases. 1, 2, 3, 4, 5, 6, 7 phases at least. All right. So, this is the way you could get a simple thing to basically rotate. Basically, is like that, simplest experimental way. Now, what Dr. Das showed is that this is the rod, this is the membrane, this is the C ring, flea proteins. There are flea G, flea M, flea N, lot of number proteins. I'm not going to bother you with the names, but I'm going to ask you to see certain things. Now, let me just go first before I come back to that slide. I want you to see one thing. There are left-hand screws and right-hand screws. Yes or no? You know what? How they differ? You know how they differ, right? Yeah, one, you will drive it in like this. One, you will drive it in like this. All right? There are two different things in real space. They have different directions. Now, you must understand that when you have a bacterial body like this, if you have a right-hand screw, the Very elementary thing is that a left hand screw rotated counterclockwise cannot push, it can only pull. The structure of the bacterial flagellum observed in some have a screw-like shape, not all flagella. Some flagella are flaccid and they just are like that. Some flagella are like a screw. But they are comprised of polymers, monomers that arrange in a left-hand screw kind of a, when they self-assemble, they assemble sometimes like this in a particular polarized manner. Now, a left-hand screw cannot. In 1970s, somebody published this and the whole world did not even bother to check this fundamental aspect. Did you understand what I'm saying? This is very fundamental. Left-hand screw can only, when it can push, it will go forward like that if it is clockwise. But the observation is not that. Observation is that the left-hand screw is pushing by counterclockwise motion. So that is not real. That cannot be real. Next, mechanism of bacterial flagellar motor. Motor. It suppose it's a motor. Now, when it is counterclockwise, these are the actual counts of protons. We have already seen this, right? A bacterial maximum without accounting for the space occupied by macromolecules, very few protons. Practically, a micro-dimension bacteria doesn't have free protons inside. Now, this course, his question, he said that he's interested in Morborn concept because how does it maintain pH? My question is more fundamental. My question is more fundamental. The idea that it rotates was fundamentally supported by Peter Mitchell's theory that the protons are pumped out and cycled. There was no question of pH regulation. Did you understand? There was no question of pH regulation. It comes from periplasm. Cytoplasm pumps it to periplasm, periplasm to cytoplasm. There was no need for anything. It was a see, this is how people change over decades without the generations knowing what's the problem. They will change this. You are witness. I'm telling you, they will change it. But they will take jolly time so that all those people sitting at the top, they will have no problem. They will save their faces without getting any shame or anything like that. So why? We make mistakes. We can accept it. What's the big deal? I also taught such things. I also did such things. But anyway, so the proton, there was no question of, this is not good for me. My neck is already, no, wait, I'll take it. Okay, I'll hold it in my hand. This protons were actually pumped out and they were coming back, like in mitochondria. Now the problem is, there is no proton. Now, the uncoupling method is that the uncoupler basically dissipates the proton gradient. This is the logic of. In 1970s, earlier the theory was that ATP was assisting. Then they said, no, it is just a proton-based idea. Now, I want you to see very clearly. Proton is what? 0.00002 angstroms. And sodium is what? Around 1 or 2 angstroms. Vibrio cholerae can use protons as well as sodium. If you have a machinery that can rotate with 0.0002 angstroms as well as 2 angstroms, my goodness, what a machinery it would be. Right or not? All right. So, you see the uncouplers. With the uncouplers only, they changed that only protons are needed. No other mechanical or all that is needed. Just this proton or later on as they say seen by why see some bacteria they are in what pH they swim around even in pH alkaliphilic bacteria pH 12 there is no question of proton there pH 12 kahan nahi then they said sodium but they didn't think about the size of the ion right are you getting it you don't need to be a rocket scientist to understand this all right now uncoupling thing the proton now you see the data applying data with a global perspective is very important if you try to say now you see pK if you want to study biochemistry pH pK 50% biochemistry you understand 50% of biochemistry you understand how to make a buffer what does a buffer do you understand biochemistry practical biochemistry now you see these are so this is dinitrophenol the IC50 is what is given in the black nanomolar micromolar nanomolar the structural aspect and the pK aspect do not seem to be affecting the inhibition if it is proton and all that you would expect and then there are molecules which don't have free protons but yet they are serving as uncouplers the point is to reason out all the kinds of data this doesn't and most interestingly this is just a structurally if you analyze it's a secretory system what is a secretory system something that puts something from inside to outside so for example have you seen the video of or pictorial rendition of how bacterial positive the sexual conjugation it has to transfer its DNA from inside and so it has to put something outside so it's what started something like that later on the toxins all that when it puts into the host that is done through such secretory mechanisms so it is a type 3 secretory system what does the secretory system do it puts some fluid or solid from inside to outside and most importantly the structural aspect when you see here you see these multiple layers it has to proceed this the whole shaft must rotate and this must be leak proof and protons are what dimension 0.0002 and it has to rotate how can it rotate as well as I told you in the cytochrome P450 area kinetic isotope effects it was rotating as well as binding rotating I want to have the cake and eat it too protons cannot come in through any other place but they have to come in through a particular place like this now before 1990s something else was the rotor then they found that they mutated we'll come to that part now here is Moorburn view Moorburn view is water goes out there is a lot of hot water produced here that goes out and this gives an apparent feeling of rotation that's it and how does it work what does a flagellar do you have seen a kite right have you seen a kite put a if you try to get it upward a small kite it goes round and round fluid dynamics doesn't work properly you put a tail it goes straight small bacterium if it pushes water out it will have only tumbling so you put a tail to it it will go in one direction if that tail has some preferable dynamic properties now if you consider this left hand screw thingy the classical model fails and also This has to rotate, this has to rotate. It's a continuous thing. The whole thing has to rotate. No, so the torque can only give very minuscule thrust. Very, it's a, even Howard Berg says it's only a 1% efficiency system. All right, if it has to go round and round, it will only give 1% of the energy that is, because you see it's a very thin thingy, and the load on this because of the length would be too high also. Now I'm not going to into the mathematical aspect. I want this video to be run. Let us see if it the video. Yes, please see this. I'm not going to comment. Can I get back to? Okay, what can somebody tell me? What did we just see now? What did we see now? Yes.
Can I say?
Yeah.
Flagella alone can rotate itself without the
Yes, but there was water coming there, right?
Yeah,
Yeah,
water was
water was coming. It did not need a rotary thing. And now, one basic thing about your sense of reality. If something is tethered, attached at one end, will it rotate? What was it showing? It was looking like it is rotating. Yes or no? So, the whole observation of rotation could have been a mirage. Now, when you see a dog, no, but there is a lot of video wherein the bead tied and all that, lot of things. I will come to that. It's a complicated thing. It's not that easy. But I want you to understand, when a dog licks water, tries to drink water, It does like that, right? What do you think it is doing? You think that it's scooping water like this, right? But it's not doing that. What it's doing is it's doing this. We think that it is doing that, but it is actually doing this. It's not pushing it towards its mandible, towards its upper jaw. It is doing it towards its mandible, lower jaw. So that's a big difference. Big difference. It's not really rotating around its rod. But then we see in certain cases when we attach the bacterium with the filament, you see the bacterial body rotates as he showed. But that rotation is only around 10 per second. What these people are claiming is that the flagella rotates thousands or more. Thousands to 10,000. It falls there. Yes. Now, these two are two different things. We'll come to it. We'll come to that discussion. I know you have worked on it. I know it is hard. I know. So the big thing is now this rotor, so-called rotor, requires protons to come in through particular places like this. So before 1990, this was the actual rotor and this was a stator. Now this is the rotor. It changed. Why? Because they saw some people mutated the amino acids that were supposed to be allowing the protons to come in. They mutated all the amino acids and they saw there was no effect on the rotary motion. So they shifted, they said this was the rotor. Now what? And they said there was a D32 that was conserved. One amino acid equally that was conserved across all these systems, they said. And that amino acid helped proton come in, and something has to come in. That was what was allowing its mechanical movement. Now, I would imagine if they said so, it is true. All that we did is Danny cross-checked. Now, you see that D32. Some people don't have any D or E, even 5 or 6, 4 or 5 amino acids this side or that side. What does it do to that mechanism? You see, multiple D's, E's. Absolutely spurious claims to back up. I'm saying this on documented. This is being documented. They said this is conserved. How dare they say that this was conserved? It's not conserved. And then the Fle-G, Fle-M, all these proteins that they were supposed to be very... See, a sophisticated mechanism like this to move clockwise, counterclockwise, all that, if it is actually a rotary motion, you would require... Can you imagine how this is? It is... Yeah, not only that, how precise the articulation has to be. If it has to be rotary, it has to switch from this to that side. It's unimaginable. And how can they move? He put a picture wherein that movement like a jaw, that ratchet movement. Now, how can that work when there's such a huge force there and you try to move here? When you switch on, even in the highly powered electrical system, we have in our house one fan switch. You switch on, it thinks, should I move? So what I'm saying is the inertial tug is so much with one. How? What is the rationale for that electrical, mechanical, or whatever force? They say it's some kind of spatial idea, and then their electrical idea. There is no real tangible way of transducing it in real space with respect to the mass and all that. They just say, they just use some equations. How does it happen in real life? Nothing. All right. So, and then The protein that is supposed to shift is this what? This shifting, this flagy. You see its structure. So we saw the structure clockwise and anti-clockwise. There is no way it can articulate like that and shift like that. For us, it doesn't appear. So fundamentally, we find multiple flaws in their aspect. And also, if it is something that rotates, you would imagine with such thing, all this there should be some conservation. You see the number of amino acids, the sizes of these relative things, they are completely different in different species. This kind of an evolutionary mechanism must be crazy. You try to make something that rotates, try to do it on your own. How difficult it is. This cannot. So now I forgot to put the image. I'm sorry, I forgot to put that image. Our theory is that the whole thing here is based on collecting reactive oxygen species, making water. And so this must be highly polar. I had that image. I should have put that image. That one image would have answered so many things. Like, you remember sodium potassium pump? That how it was having so many arginines there. Here, all that it has is highly polar and charged, packed like this here. So what it does is water, superoxide, peroxide, radicals, all the focus, make water, heat, boom. And there is a ATPase like switch here, which is a mechanical switch. ATP hydrolyzes, water goes out. That's it. It's a jet propulsion kind of a thing, but not taking from outside and pushing it. That, what was his name? Low Reynolds number, Purcell. Purcell put the, because bacterial flagella at this, they are in low Reynolds regime. In low Reynolds regime, inertial forces cannot act. So, you know, bivalves, what do bivalves do? They take water, for example, octopus, for example. How does it do? Takes water, boom, pushes it out, and then moves forward, right? That cannot be possible in this. But what is happening here? It is not taking water from outside and pushing it outside. It is making water inside and pushing it outside. And there is one lab in Caltech that has given the math for this. So, clearly, what does the flagella do? It stabilizes the fluid dynamics. And that multiple types of flagellar structure are there. So, you imagine if it is rotary movement, how will different kind of flagella, how will they accept? Very simple, water goes. Some things can go like that and they can assemble. It is not always helical. Some are very flaccid also. So the push and pull, and most importantly, this, there is no beating this. There is no beating. As Sir said, there was nothing to rotate it, but it was rotating. Second point, it was attached at one end. How can it rotate? There is no scope. There goes the theory of mechanical rotation. What does it do to science? You have a tangible way to understand evolution now, right? How can something move? Suppose a chlamydomonas, it doesn't have a brain, but it has light coming in. So the light is coming from this direction. How can it choose to move there? When the light comes there, ROS gets produced, they get water, and then it moves, it continues to move in that direction. Did you understand? It's a very simple logic. Very simple logic. There is no need for a brain to decide to move, how to go. The tumbling motion that he talked about is when water goes out, it stops. So there is a misbalance of forces or something, and then it cannot maintain that direction. And then once again, water jets out. That's my interpretation, right? My interpretation has no flaws till now. It is not proven either. But the current interpretation is definitely has got multiple problems. Yes, and for me, when somebody works a lot of time, like, and then somebody questions that it is not a pleasant thing. Nobody wants to do that. Nobody wants to see their lifetime activity going into waste. You don't want to waste your time in something that was wrong. So when one of, I don't want to talk about it. So somebody, one of my students, it's painful. Um, he started doing this PhD project on this. I said, this is a false framed question. Don't do your work on this. 1 second. So he did it, but anyway, he also bought it. Dr. Das also thinks that ideas are good, but then there is a significant amount of traction on that.
Yes, I want to discuss.
Yes, we will discuss that later. Now, so it's your discussion. Your discussion now. Go ahead.
Yeah, no, actually, I strongly agree with Marwan theory, but actually, I have some I need some discussion regarding the rotational concept. Yeah, because so precisional motion, you can see the precisional motion is observed, and I also mentioned one paper. Professor Eric Lauga, yeah, he just written in. It is published in Physical Review later. It is a well famous journal. So he showed that if for our shear flow, if in a shear flow, so filament actually making polymorphic transformation, and he mathematically proved.
Yeah, we saw that video.
It is also at a polymorphic transformation.
No, but
yeah.
that is because the flow.
Yeah, exactly.
The flow can change it.
Yeah.
The flow can change it.
Yeah,
That's
exactly.
what we saw.
Yeah, exactly.
Yeah.
So that's why actually lot of discussion and lot of hydrodynamic study. Still, actually, I suggest Professor KMM that we have to perform lot of hydrodynamic study to establish that. Yeah, and another actually I suggest that okay, we have to need some lot of discussion about the experimental evidence like that. Yeah, so if it is possible, so for H plus moving out of H plus. Yeah. So this is, but I strongly believe the Marwan concept that what is the how actually bacteria actually maintain this type of pH. I just tell in terms of pH, yeah. But already this answer
the point is
yeah.
When the field came, we should do this.
Exactly.
And people should see that.
Exactly. Actually, this
That's
is
what
actually
they
the
should.
hybridization of the new classical and Marwan concept.
Yeah.
I think so. And we
There
are
is no
trying to-
hybridization.
No, means
There is no hybridization.
no,
The
means
classical was wrong and the new is right.
No, I have a new theory.
There is no concept of
theory.
hybridization.
Yeah,
Because here, when we have a theory, it has to build ab initio and it has to be placed in proper foundation. And that foundation is when you try to, now, can I just take a, 1 second. A speaker comes to a classroom and takes a mug, a jug, and puts 3 big stones in it. All right, this is very important. This is a very important story. Stories everybody can understand. Data and mathematics people can't interpret. Stories everybody understands. Very simple. So he takes a jug, puts 3 stones in it. The jug fills in. So he asks people, can we put anything anymore in this? Some people say no. Then he says, wait. He takes smaller stones, puts it in. Then he says, can we put any more in this? Then he takes some sand, puts it in. Then he says, can we put any more in this? He takes some water, puts it in. Now he says, try to extrapolate this with respect to your life experience, your approaches, all that. So some kids stand up and say, you think you can only do this much, but you can still do more. One good thing. So many people give so many interpretations. He says, if you take it as a problem solving or philosophy towards life, what does this experiment just that I did, the demonstration that I do now, what did it show you? That is, you have to put the larger stones in first to solve a problem. To get the approach in your life, you have to prioritize, explore, resolve, prioritize. Here you have a problem. It's a jigsaw puzzle. There are conflicting observations. First thing that you have to put is, what will you put? What is the most important thing that you'll put? Such a problem. Assembling something across 7 faces without leaks. How can something be rotated by protons as well as by sodium? What is the dimension difference? 10 to the power 5 to 10 to the power 6. There is no scope for the other theory. Absolutely no scope. And then these are proteins. And then counterclockwise moving, all that energy yields nothing. It's a simple thing. The structure, secretory system, very clear. They are just assembling, sealing it. It becomes tight. Enough. Water goes out. We have seen the other experimental data. There is no need to discuss anything any further. As far as jettisoning the older idea is concerned, it is wrong. Hook, nail and sinker, it is wrong. But regarding the new idea, there is a lot to be discussed. Because for example, we don't know how does the water come out like this. I have just shown this. Water comes out from here. That is what is to be deemed. And I don't know. I don't have the facility. I don't really care much now for this. For me, the problem is salt. For me, it is disproved. I've given a new avenue. For me, that nuts and bolts, but that is what is important. That's what runs life. But the selfish guy that I am, my challenge is to, there's some intellectual kick I get and I move on. That's it. That's bad actually. That's that's not great. No, that is not great. For me, until it is useful to people, it is a worthless idea. It's just an esoteric pursuit. No. Life is all philosophy. There is some path as well as a goal. Both path and goal are essential. Yeah.
Very important. If you have been stuck to a particular one problem only, then other problems could not be attended.
Yeah, that is true. But yeah, that is true. That is true. But for me, yes, it has to. Yes, I agree with that. I agree with that.
Somebody else can be some idea you got.
Yeah. Good way of doing it. Absolutely, I agree with that.
It is not about your self-esteem. Responsibility once you take it, the world that this is an idea.
I agree with you 100%. Yes, that is why recently I showed you that the first slide that I put, Albert St. Georgi, he said there are scientists of two kinds, Apollonians and Dionysians. Now Apollonians, that systematically they fill in the gaps and take students, get funds and they do that. Dionysians like me, boom, 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 they go. Now, both are important. I'm not negating the other one. But I want the Apollonians to, yeah, they have come. Let's come. Yeah. So the tea is come. Sir has come. Sir, no? Okay. So the tea has come. What is the time now? 10:54. Yes. Now, yeah.
Sir, as you said, many people are working in a field with the classical knowledge and classical R&D they are doing and wasting.
Pay attention, please.
Wasting,
Discussion is where science is.
And many have wasted. They feel that they have wasted their time and energy and money. So basic understanding of the science. That science is a part where the mechanics, physics, chemistry, mathematics, and mechanics. If this would have been understood better at the lower level of education, undergraduation, then further research could have been stopped by themselves. That there is some mechanics problem is there, or there is some mathematical problem is there. So the basics to start with a PhD or research is to fully understand at undergraduate level physics, chemistry, and mathematics.
Correct.
So these three subjects must be studied in three years, which
yes.
we did. When I did a food technology, the course was designed as it. If you don't do BSc mathematics, physics, and chemistry, you will not get admission to the course.
Yes.
So it was very easy to learn other things.
Yes, choice. Yeah. So my as far as learning is concerned, I think the most important subject to learn is what, Huh? Mathematics, yes, our dean loves mathematics and all that. For me, stories. When you are kids, the stories you learn, they are the most important thing. Hans Christian Andersen, Raja Nanga hai, that concept. Pied Piper of Hamelin. People are led, rats. You know that what is shown is that when I was young in first class or second class, I studied a beautiful story. Three fishes. Three fishes. They are in a pond, Kerala medium school, and once they're happy, they're living in a pond. Everything is nice, resources. So some guys come around and say, "Hey, come on, this pond is filled with fishes. Let's cast a net next weekend here." So one of the fishes, overhears that. And don't ask me how the fish heard it, okay? Don't put your rational mind here. Okay. Story is a story. There are some. Yeah. So, yes. So, fish, yeah. No, but language, I said the other side also. Hathi chalayega kaise? So, yeah. So, the point is that the fish goes and lets the other person know, other two fishes know. He says, "Hey, look, I heard this. They're going to cast the net. We better move out." So, the second fish says, "You know what? I heard it. I think there could be some purpose in it. But I like this place. Let's see. If it comes, आएगा, देखा जाएगा. ठीक है? Then this third fish says, बहुत देखें. क्या है यहाँ इतने साल से जीते आ रहे हैं. We have been living here for so long. Nothing's going to happen. That weekend comes, that people come, they cast the net. By that time, the first fish has already taken a small canal. It has gone to another water body. The second fish is a street smart fish. What it does is it pretends that it is dead. Floats on top of the water like this. So the people take it and just throw it, in Kerala local. So it's in a pond nearby paddy field. It also falls in because they don't want to consume something that is dead for what reasons, So third fish gets caught, gets fried, gets eaten. Moral of the story. Stories are here to teach you basic approaches in life. I tell you, the fundamental message that you should take from this is chance favors the prepared mind, explore, resolve, prioritize. Pursuit of excellence is based on what you have and what you know. These three messages. Not major things that you learn in textbooks, all this. My life pursuit has been based on these three philosophies. One second, sir. आप बीच में वो बोलेंगे ना जब फ्लो में रहता ना आदमी को गाड़ी चलाने दीजिए. एक मिनट चलने दीजिए जब फ्लो में रहता ना आदमी को जाने दीजिए. आपको समझना चाहिए. नहीं yeah. So do you understand that? Because when Narasimhan sir showed me and said something like that he builds on what he knows. Krishnadas, I built on what I knew. When I prioritized solving the stones, then chance favors the prepared mind. It was not said by me. Who said that? Pasteur. You know Pasteur? Yeah. Our bio people's core. So these people have built their lives on fundamental philosophies that they have learned through stories that you do learn when you are young. So the younger you are, the better you can learn, because otherwise our learning. So I think yes, you wanted to say something. I will go.
In our curriculum, we used to learn a lot of stories based on Panchatantra and some based on the yoga, Vedas and all that. So Rishi Munis were knowing that these are required to learn by the people at a younger age. Very important. And our forefathers or our relatives, which are elder at that time, they used to tell us the story. Lot of stories from Pancharatna. We do not have to read at that time. Say 5 years, 3 years old, we do not have any chance to read. But they used to tell. So if you have a joint family with the father, grandfather, everybody, then this thing works. And now that is been killed. So people are not able to learn the stories.
that intelligence has lost, and now people like this so-called modern people, they don't want to go into the intricate details. Why the story is told, even that is not that is lost.
Now, people are going. Yeah, please. Yeah, please have your refreshment.
Hard reality.
Hard reality. We get to now. People don't need stories. Visual. Your nerves are all visual. Quick, quick. Please go ahead. Use that. Get that. And then we will. सोमन सर को बुलाते हैं यार. Anything. Where's my phone? Develop global problem. We don't use that please, because we don't can solve the global problem. All global problem, basic problem, global problem क्या है? What is basic global? Fighting. Each and every country is fighting. So again, it is the basics of the biotechnology. Basics. If you don't know this, I'm not a biotechnology even then. But I have learned. रात को प्रिपेयर कर रहा हूँ